The world is watching as one of the most ambitious projects in modern space exploration takes shape, a project that could shift the balance of power in the new space race. For decades, the dream of reaching the moon again has been framed by the achievements of the United States and the legacy of the Apollo program, but now a new player is stepping firmly into the spotlight. Hello everyone, welcome back to the Global Conflict News channel, and please make sure you subscribe to the channel so you never miss an update on the shifting events of this technological rivalry that is rapidly shaping the 21st century. Today we are talking about China's next great leap into the cosmos, its moon rocket, the colossal Long March 10, which has now entered its final phase before flight. This is not just another piece of machinery to roll out of an assembly line, but a statement of intent by rising power that sees space not only as a frontier for science, but as a theater of national prestige, competition, and potentially even conflict. The very sight of this rocket on the ground evokes awe, and as we explore its design, both exterior and interior, its performance, safety systems, unique selling points, and even the costs associated with such a mammoth undertaking, we will unravel how this machine embodies both engineering triumph and geopolitical ambition. Standing at over 90 meters in height, the exterior of China's moon rocket is a marvel of scale and design, reflecting decades of evolution in the Long March family. From the outside, its sheer presence cannot be overstated. Imagine an engineering tower of steel, composite materials, and precision craftsmanship, its skin gleaming white with markings in bold red characters announcing its origin. The rocket is designed not only to fly but to symbolize, and every curve of its fuselage, every fin, every separation stage has been tested, simulated, and refined to withstand the unimaginable forces it will encounter. The base is flanked with gigantic boosters, arranged to deliver raw thrust on a scale rarely seen outside the Saturn V or NASA's modern SLS. As one gazes upward, the upper stage narrows into a sleek aerodynamic fairing that shelters the crewed lunar module, the very capsule that may one day carry Chinese astronauts toward the moon's surface. The exterior is coated with thermal protective materials to resist the violent conditions of launch, and the visible design choices also hint at subtle advancements in aerodynamics that make the vehicle more efficient than its predecessors. The rocket does not simply look powerful, it exudes a kind of engineered inevitability, as though every bolt and rivet has been placed to fulfill a role in one of humanity's most ambitious journeys. But what lies within is equally fascinating, for the interior of this rocket is not a simple hollow tube packed with propellant tanks, but a carefully choreographed space where technology, safety, and human presence converge. Step inside, at least in imagination, and one finds a labyrinth of tanks, pipelines, structural supports, and the critical crew module where the human element meets the machine. The propellant tanks themselves are colossal, designed to carry liquid hydrogen and liquid oxygen, fuels that must be maintained at cryogenic temperatures and pumped with extraordinary precision into the engines. Insulated walls and advanced monitoring systems ensure these fuels remain stable until ignition, for even the smallest fluctuation in temperature or pressure can mean the difference between success and catastrophe. Engineers have spent years refining these systems to eliminate inefficiencies and reduce risks, using computer modeling and extensive ground testing to perfect the interior arrangement. The crew capsule, secured at the top, is perhaps the most human-focused part of this towering structure. Here, astronauts will be strapped into ergonomically designed seats that are engineered to absorb the brutal accelerations of launch. The walls of the cabin are lined with advanced instrumentation, touchscreens, and redundant control systems, offering astronauts both manual and automated options to guide their mission. Within this interior, life support systems quietly hum, recycling oxygen, removing carbon dioxide, and controlling temperature to maintain a habitable environment in the void of space. Water storage, waste management, and emergency supplies are carefully tucked away, all while ensuring weight efficiency and safety margins are maintained. To make the journey tolerable and survivable, everything from lighting systems to insulation against cosmic radiation has been integrated with meticulous attention to detail. What makes the interior especially notable is the emphasis on redundancy and autonomy. Unlike earlier eras of space exploration where astronauts often had to manually correct or adjust flight parameters, this capsule is infused with artificial intelligence and real-time monitoring systems that can predict and react to anomalies faster than any human could. Should a problem arise, automatic abort sequences are ready to separate the crew capsule from the main booster in milliseconds, deploying parachutes and safety mechanisms to bring astronauts safely back to Earth. This philosophy of layered safety represents lessons learned not only from China's own space program but also from decades of global experimentation, triumphs, and tragedies in human spaceflight. The systems inside this rocket are not simply about enabling a mission, they are about ensuring that human lives can be safeguarded against the unforgiving environment of space. The interior structure also reflects a balance between strength and efficiency. To carry the massive payloads required for lunar missions, including the lunar lander and cargo, engineers had to rethink traditional interior layouts. Reinforced frameworks support the enormous stress loads of ascent, while lightweight alloys and composites reduce unnecessary mass. Cabling and wiring are arranged with military precision, routed through channels that minimize electromagnetic interference while allowing for easy access during assembly and testing. Each sensor, each actuator, each circuit is part of a symphony of engineering designed to keep the rocket operating seamlessly. Even vibration control systems are embedded throughout, as the shaking and acoustic energy of launch can be as destructive as the heat and pressure itself. When we consider the scale of this interior, it becomes clear that this is more than just a transport vehicle. It is a small, self-contained ecosystem, a moving fortress against the harshest conditions nature can throw at humanity. One must remember that while the rocket will roar for only a few minutes to deliver its payload into orbit, the systems inside must endure stresses greater than anything on Earth. The transition from stillness to controlled explosion, from the crushing pull of gravity to the weightlessness of orbit, happens in minutes, and every interior component must work flawlessly throughout. Yet beyond the immediate functionality, the interior also represents a vision. This capsule is designed not merely for one mission but for a series of lunar expeditions, possibly even extending into preparations for future Mars exploration. Its modularity allows for upgrades, its interior systems can be replaced with newer technologies, and its layout reflects an understanding that this is not a single-use venture but part of a long-term commitment. From the astronaut's perspective, the capsule offers both the reassurance of safety and the inspiration of possibility, for within these walls they are not just passengers but pioneers carrying a nation's ambition. China's engineers have also paid close attention to ergonomics and the psychological demands of space travel. The interior, though compact, has been arranged to minimize claustrophobia and maximize efficiency of movement. Lighting systems mimic natural cycles to reduce stress, seating is configured to optimize communication and teamwork, and storage is strategically located to ensure quick access to critical supplies. In an environment where small inconveniences can escalate into dangerous distractions, these design considerations could be decisive. The cabin also includes display systems capable of projecting mission data in highly intuitive formats, allowing astronauts to maintain situational awareness with minimal mental strain. In essence, the interior is not just a technical environment but a human-centered space, crafted to support individuals as they undertake one of the most demanding tasks ever attempted by their species. As we move deeper into the examination of this interior, we see the reflection of a larger truth. The rocket is a blend of national ambition, scientific innovation, and human resilience. Every detail has been argued over, refined, and perfected by teams of engineers who know that mistakes are unforgiving at this scale. This attention to detail is evident even in the smallest design elements, from the arrangement of pressure valves to the layering of insulation materials. Each element tells a story of rigorous testing, of lessons learned from both success and failure, and of the immense pressure to succeed in the global spotlight.